Okay, thorium-234 has a half-life of 24 days. Okay, half-life of 24 days. The initial activity of this isotope is 10 microcurie. Determine or calculate the activity of the isotope after 72 days. Okay, good. So thorium is a unstable radioactive substance. Okay, radioactive nuclei. This is the half-life. Okay, I'll write that down. Okay, this is the half-life. Be careful, the unit is in days. You see, in days. So not second, not SI unit. And then another thing is the activity also not SI unit, is microcurie. So be careful with this. This is initial activity. Initial activity, that means activity at 0 second. Activity at 0 second. Okay, activity, this is the activity. Activity means A lah, or you can write this as dn dt lah. Okay, activity dn dt. So you want to put dn dt also can, you want to put A also can, yeah. But this one is initial activity, so you should put that as A naught, or can this one is dn dt naught. Yeah, that means activity at 0 second, A naught or dn dt naught. Okay, calculate the activity after 72 days. That means you want to find the final activity. Final activity at this time. This is the time taken. So now the time taken is 72 days. Yeah, 72 days. So be careful with the unit. You see that? The unit. All right. So first we do the question A. Okay, question A. So what formula we use for this one? Yeah, of course we use the exponential law. Exponential law of radiative decay. This exponential law can use the number of nuclei, activity, or mass. So got 3 things can be used. So this one is about activity. Yeah, about activity. So I can use A equal to A naught exponent negative lambda t. Use that formula. A equal to A naught exponent negative lambda t. Or you can also write it as dn dt equal to dn dt naught exponent negative lambda t. But normally we don't write so much. We just write as A lah. We don't write as dn dt lah, because this one, why you want to write so many alphabet? Yeah. Okay, just use this one, simpler one. And also this one, you of course we know that activity always negative value, isn't it? Normally we write like this one, activity we always write as negative 0. microcurie, right? But this time we just ignore the negative sign lah. For this time, yeah. Next time just ignore, don't put the negative sign. Just ignore the negative. When we substitute, this negative means the nuclei decay. Yeah, the number of radiative nuclei is decreasing. But to substitute in this equation, we just ignore the negative sign. Okay, only that before the previous questions about this one, when you use the dn dt equal to negative lambda n, this one you cannot ignore. You must put the negative sign. This one you must put the negative sign. But for these questions, okay, for these questions, when you substitute the A naught, you just ignore the. So for this time, this A naught, you just ignore the negative sign lah. Okay. So what I want to tell you is, this one, just ignore the negative sign. Yeah. Even you put negative sign for A and negative sign for A naught, this negative also they cancel each other, become positive. Okay, become positive. So for this time, you just ignore negative sign. But last time, the previous question for this one, dn dt equal to negative lambda n. This dn dt, you must put a negative sign. Yeah, you must put a negative sign. But for this one, this question, you can ignore the negative sign. Okay, just put as positive. Just put as A naught equal to 10 microcurie. That's just that. Okay. Another thing is this curie is not SI unit. It's not SI unit. Basically, we know that you know what is curie. Curie, 1 curie is actually 3.7 exponent 10 becquerel, or 3.7 exponent 10 per second nuclei decay per second. Okay. So I'll write that down. Okay. Actually, 1 curie means there are 3.7 exponent 10 of nuclei decay per second becquerel, or 3.7 exponent 10 nuclei decay per second. Okay, nuclei decay per second. So it's a very big value. Okay. Yeah, the SI unit actually is per second or becquerel. It's not curie. However, looking at these questions, I can see that both have the same unit. The A and A naught both will be the same unit. Initial activity is microcurie. Okay, and then the A also will be in microcurie. So it doesn't affect much. So you can just leave it at microcurie. You no need to change it to per second. Understand? You no need to change the activity into unit per second. You just leave it as microcurie, because A and A naught, this one have the same unit. So no need to change to SI unit, unless you are in previous questions like this one, dn dt equal to negative lambda n. This one need to be in per second. Okay, because the lambda is per second. Okay, let me write it down over here in these questions. If you are using another formula, which is dn dt equal to negative lambda n, or this dn dt is actually A, negative lambda n. This one, because the lambda is unit per second, so the activity need to be per second. It's a must. Okay, this activity you must change to SI unit. So for this question, you must SI unit. Yeah. But for this one, the SI unit, not a must lah. SI unit not a must. Yeah. So it depend on the equations. Okay. For this question, the activity must be in SI unit per second. Okay. Must change the activity into per second. So the microcurie, you need to change to per second. Yeah. You can write A equal to negative lambda n, or you can also write the equation as you can also have initial activity equal to negative lambda, then this one will be also initial nuclei. So this one must be per second, because the lambda is per second. Okay, because the lambda is per second, so the A naught must be in per second. But for this one, because A with A naught, they have the same unit, microcurie, so it doesn't affect. I can leave it as microcurie. No need. It's not a must. Yeah. This one is not a must. This one is must. Yeah. This one is not a must. SI unit not a must. This one is a must SI unit. Okay, for activity. And also looking at the time here, our time is in days. So our lambda, you know, my half-life is 24 days. So we know that according to the equations, lambda equal to ln 2 over half-life. That's the formula, isn't it? My formula for lambda is ln 2 over half-life. Lambda is ln 2 over half-life. So it's given that my half-life is in days. So my lambda here is the unit per day. Understand? It's unit per day. So that means my lambda here, this one is per day, and my time can leave it as day. Understand? Because these two units, they cancel each other. This is the index number. These two units can be cancelled. Yeah, day and per day can be cancelled, and then microcurie with microcurie can be cancelled. Understand? So that means okay, just want to put it beside here. Okay. So what I can say is the SI unit is not a must here. The SI unit is not a must because the lambda is per day, the time is day, so they have the same unit. So the lambda no need to change to SI unit per second. You can just leave it as per day. The time also can leave it as day, and then the activity also, they have the same unit. You can leave it as microcurie, unless you are using these. You are using these. Then this one is a mass SI unit. This one is mass SI unit. The lambda need to be in SI unit per second. Activity also must be in per second. So right now this one is not a mass. Yeah? SI unit is not a mass. The lambda, you can leave it as per day, the time as day, and then the activity and initial activity, you can leave it as microcurie. Yeah, no need to change to SI unit. So to save your work, understand? To save your work. Okay, that's good. Yeah. So right now, let's find out our lambda first. Okay, our lambda. So our lambda is let's calculate lah. Our lambda is ln 2 over what is it? Ln 2 over half-life. My half-life is 24 days. So just leave it like this lah. In unit per day lah, lambda, yeah, 24 days. So and then I can substitute into lambda here, and then okay. And then initial activity also can be substituted here. Just ignore the negative sign for activity. Okay, now I can do my work. Okay, my initial activity is okay. Just ignore the negative sign. Just put as 10. But you must write down the unit with you. Because this is not SI unit, you must write the unit together with the value when you substitute value. Yeah, don't just write the value. You must write the unit with value. Okay, and then this initial activity A0. Okay, and then exponent negative. What is my lambda? My lambda is ln 2. Okay, wait, I think I need to let's pull this a little bit here. Yeah, ln 2 over half-life. What is my half-life? My half-life is 24 days. Okay, just substitute here 24 days. Okay, and then here my time taken is 72 days. 72 days. Okay. So yeah, just over here a little bit. Okay, so now I can calculate. I can cancel. That's why you see I didn't find out my lambda. I didn't calculate first. Yeah, I no need to find the value first, because why? This I straight away substitute this whole thing into here, because this 72 can be divided by 24. That's why I leave it as equation. I don't find the value first of lambda. Because I want to cancel. I want to play cancel. Understand? I want to play cancel. So 24 days and 72 days. Okay, 72 divided by 24, it is equal to 3. It is equal to 3. So okay, and then So let's calculate. Yeah, let's calculate. So this one I got 10 microcurie exponent negative 3 ln 2, isn't it? Because cancel divided, I got this one is 3, so 3 times ln 2, 3 ln 2. And then what is the activity after 72 days? Let's calculate. So 3 times ln 2, 3 times ln 2, I got, okay, this one, and then I do exponent, to the power of this value, okay, wait, of, okay, again, 3 times ln 2, 3 times ln 2, and then I have, this one has a negative, okay, it has a negative, and then exponent to the power of this answer, exponent of this answer to the power of this answer. I got okay, and then I multiply by 10 microcurie, 10 microcurie. So my activity is 1.25 microcurie. That's my final activity after 72 days. Okay, so I got it, the answer, right? Just leave it, no need to calculate first, yeah, because you can play cancel later on. Okay, later on, what is the time taken? Yeah, what is the time taken for activity to fall to 2.5 microcurie? So now he asked to find the time taken, the final time taken, and then when the activity has fall to this, so this is the final activity. So it is the other way around. It gives you the final activity, asks you to find the time, So okay, it's the same equations. You're going to use back the same equations. Okay, now question B. Use back the same equation. A equal to A naught exponent negative lambda t. Okay, so I got the final activity. Yeah, it fall to is fall to, not fall by. Fall to this value. So this is the final activity. So please write 2.5 microcurie. Okay, so my initial activity also, it will be in curie. Oh, my initial activity also, I got it. Initial activity is 10 microcurie. Is 10 microcurie. 10 microcurie. Ignore all the negative sign. You see, ignore all the negative sign, and then exponent negative. What is my lambda? My lambda I just maintain as this one, ln 2 over 24 days. Ln 2 over half-life. Yeah, ln 2 over half-life. Ln 2 over 24 days. Ln 2 over 24 days, and then time taken. So continue. So this one divide, 2.5 divided by 10. 2.5 divided by 10, I get what? I get 0.25. I get 0.25, and this one exponent negative ln 2 over 24 days. Time taken. So okay, ln both side. I ln both side. Ln both side. Ln both side. Okay, I ln both side. Then the whole thing goes down. The whole thing goes down. The whole thing goes down. And then here is ln e. Yeah. This whole thing goes down. Yeah. This whole thing goes down when I ln both sides. I go to the side here, and this one is ln e. I know that ln e is equal to 1. Ln e is equal to 1, isn't it? Ln e is equal to 1. Yes, that's right. Ln equal to 1. So I can find my ln. What is value of ln 0.25? Ln 0.25 is it is actually negative 1.386 2944 something, yeah, and then equals to negative ln 2 over 24 days t. So yeah, 1.38 62944, yeah. Okay, and then multiply by 24 days, and then divide by ln 2, divide by ln 2. Okay, wait, so okay, wait, again, negative 1.38 62944, and multiply by negative 24 days, divide by ln 2, multiply negative 24 days, and then divide by ln 2. So my time taken is 48 days. 48 days. Yeah, that's the answer. My time taken is 48 days. Okay. My time taken is 48 days. So this one has undergone, you know, my activity. This is my initial activity. Yeah. So this one has undergone 2 times half-life. Isn't that? My half-life is 24 days. My half-life is 24 days. So this is considered twice half-life. Twice half-life, yeah? Twice of the half-life. So yeah, if you look at the 10 microcurie to 10 microcurie to 22.5 microcurie actually is initial activity start with you know, 10 microcurie. Then after a half-life of 24 days, it becomes 5 microcurie, isn't it? 5 microcurie, and then another half-life of 24 days. It is divided by 2 again. It becomes 2.5 microcurie. 2.5 microcurie. So it takes up a total of twice half-life, which is 48 days. See that? So that's why 10 become 2.5. 10 become 2.5 after half. So that's the concept of half-life. It become half and become half. After twice half-life, that means half and half. So 1/4, yeah, is 1/4. Okay, that's 48 days. So that's all for these questions, yeah. I hope you understand, yeah. Very straightforward questions, and that's the answer, yeah. Hope you understand and like it. Bye.